Hello students, welcome to Physical Science Digital Classes Mahabubabad. Myself Narendra Babu PGD Chemistry, TSMS Mahabubabad. Today in this session we are going to discuss about classification of elements in the periodic table. In this we are going to discuss about part 5 of the topic periodic properties of the elements in the modern table. The topic is periodic properties of the elements in the modern table. In this, the physical and chemical properties of elements show a regular variation in the periods and groups of the periodic table. That means the physical and chemical properties of the element show some regular variation in the periods and groups of the periodic table. The various properties of the elements change on moving across a period or on moving down in a group of the periodic table. These are called characteristics of periods and groups in the modern periodic table. Actually, the various properties of the elements, so like atomic radius, ionization energy, electron affinity, electronegativities, so such type of the properties while we are moving across the period or moving down the group, and they will change, and they shows variations in their properties in this periodic table, and these properties are called generally characteristics of period and groups. Okay, these are generally called as characteristics of periods and groups in the modern periodic table. So those different types of the characteristic or characteristics of the groups and periods are, first one is valence electrons. First one is valence electrons or outermost electrons. On moving from left to right in a period, the number of valence electrons in elements increases from 1 to 8. Now let us discuss about how valence electrons are present in periods and groups. On moving from left to right in a period, the number of valence electrons in elements increases from 1 to 8. For example, if we observe this, this is the example of elements of period, third period. In this, if you observe, so in this electronic configurations, okay, let us see the example here. In this elements of this third period, mean this sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine and argon. While we are moving from left to the right in this case, so in this electronic configuration, the number of valence electrons increases from 1 to 8 when we are moving from left to right. When we are moving from left to right, so it is increases. Clear? This is about the valence electrons, how they changes in these periods. In this, the first element in every period has one valence electron, and the last element in every period has 8 valence electrons. Okay, so in this, if you take the periods in the periodic table, the first element is generally having the valence 1, and the last element of the period. So when we are moving towards the right in the periodic table, so the last element that is having the 8 valence electrons, except the first period, so that is hydrogen and helium will be present. In that, helium is generally having only 2 valence electrons. Helium is having only 2 valence electrons. Except this, the valence electrons are 8 of the last element of the period. The electronic configurations of elements in a period change in such a way that the number of electrons in the outermost shell of their atoms increases from 1 to 8. The electronic configurations of elements in a period change in such a way that the number of electrons in the outermost shell of their atoms increases from 1 to 8. For example, in the third period, the electronic configurations changes from 2, 8, 1 in sodium to the 2, 8, 8 in argon when we are moving from left to right. So for example, just now we have seen the third period. In that electronic configurations, they change from 2, 8, 1. That means 1s2, 2s2, 2p6 and 3s1. in sodium to the 1s2, 2s2, 2p6, 3s2, 3p6 in argon. Okay, that means 2, 8, 8. Outermost is 8 in argon. For example, if you see here, so this is the electronic configurations in this sodium is generally having the 2, 8, 1. So number of valence electrons 1, and coming to the argon 2, 8, 8. That means outermost electrons are completely filled. Electronic configuration it is having in this. That means the number of valence electrons are 8. All the elements of a group of the periodic table have the same number of valence electrons. So if you go through the groups now, so group in the sense the vertical columns are generally called as groups. In groups, all the elements of the group in the periodic table, they are having the same number of valence electrons. If you compare it to the periods, so if you consider it in periods from left to right, so the valence electrons will change. The number will change from 1 to 8. But coming to the group, the valence electrons from top to bottom, so they are having the same number of the valence electrons in a group. For example, all the elements of the group 1, let us take here, this is the group 1. So lithium, sodium, potassium from top to bottom, lithium, sodium, potassium. In this, all the elements of the groups of the periodic table like lithium, sodium, potassium have one valence electron. What is the valence electrons in these elements? In the sense 1. Why? Because if you see the electronic configuration, the outermost electron is 1, and for the lithium and for the sodium also outermost electron is 1, and for the potassium also outermost electron is 1. Have you got the difference? If you go through the periods, the valence electrons, the number of the valence electrons, they are changing from 1 to 8 when we are moving from left to right. But in the groups from top to bottom, so all the elements are having the same number of the valence electrons. For example, group 1 in this, they are having the valence electrons 1. The atoms of group 1 elements, lithium, sodium and potassium, can lose their 1 valence electrons and easily to form positive ions like Li plus, Na plus and K plus, potassium plus respectively, having 1 unit positive charge. That means the first group elements like lithium, sodium, potassium elements, so they are having the valence 1 and they can easily lose that electron and then be able to form the cations. Okay, and which is having the 1 unit positive charge in it. So group 1 elements are monovalent, having valency of 1. So group 1 elements are having the monovalence. They are called as monovalent. They are having valency 1. On moving down in a particular group of the periodic table, the number of valence electrons in these elements remains the same. On moving down in a particular group of the periodic table, the number of valence electrons in the elements remains the same. All the elements of group 2 have 2 valence electrons each in their atoms. If you take the group 2 elements, they are having the 2 valence electrons each in their atoms. For example, so the elements beryllium, magnesium, calcium of the group 2 of the periodic table have, if you see, 2 valence electrons each of their atoms. They are having the second group elements, they are having the valence electrons 2 in each element. So similarly, group 13 elements means group 3 elements. So elements have the 3 valence electrons each, and group 14 elements have 4 valence electrons each. Group 15 elements have 5 valency electrons each. Group 16 elements have 6 valence electrons each. And similarly, all elements of group 17 have 7 valence electrons each in their atoms. And what about the 8th group elements? All the elements of the group 18 means 8th group elements, which is also called as 0 group elements, have 8 valence electrons in each of their atoms except helium. Why? Because in these 18th group elements, helium, neon, argon, krypton, xenon, radon. In this, so except the helium, So all elements are having the 8 valence electrons, but helium is having only 2 valence electrons in its outermost shell. The valency of an element with respect to hydrogen is equal to its traditional group number. So that means, so let us take the group 1. Okay. Let us take the group 1 elements. What is the valency of the group 1 elements means? Its valency is equal to its group number. That means what are the group 1 elements? Lithium, sodium, potassium, rubidium, cesium and francium. And if you see this, so the valency of these elements is equal to its group number. And similarly, group 2 elements valency is equal to 2. What are the group 2 elements? Beryllium, magnesium, calcium, strontium, barium and radium. The valency of group 3 elements is equal to 3. What are the group 3 elements? Boron, aluminium, gallium, indium, thallium. And coming to the valency of the group 4 elements is equal to 4. What are the group 4 elements? Carbon, silicon, germanium, tin, lead. These are the group 4 elements. Up to group 4, the valency of an element with respect to hydrogen is equal to its traditional group number. Clear? If the element is in the group 5 or above, that means up to 4th group we have seen. So its valency is equal to group number. But above the 4, 4 in the sense from 5th group to the 8th group, its valency, so from 5th group to the 8th group, its valency is equal to 8 minus its group number. This is the formula actually how to follow, 8 minus group number. For example, chlorine valency, in the sense chlorine is that belongs to the group 7. Okay, what is the valency of the chlorine? Chlorine valency, if you want to calculate, we have to follow the formula, this formula, that is 8 minus group number of the chlorine. 8 minus 7, that is equal to 1. What is the valency of the chlorine? 1. Clear? The valency of the chlorine is 1. Now, all the elements in a group have the same valence. If you take any one of the group and those group elements, they are having the same valency. For example, first group elements, all the elements of the first group elements, they are having the same valency. Okay, right. So on moving from left to right in each short period, the valency of the elements increases from 1 to 4 and then decreases to 0. On moving from left to right in each short periods, the valency of the elements increases from 1 to 4 and then decreases to 0. So when we are moving from left to right in a period, what about valency in a group? If you take any one of the group, so that group is having the elements of that group that is having the same valency. But in a period when we are moving from left to right, so valency increases from 1 to 4 and then decreases to 0. This is the first group element. Valency is 1. Second group element, valency 2. Aluminum is the third group element. Valency is 3. Silicon is fourth group elements. Valency is 4. Up to fourth group, the valency of the elements equal to its group number. But coming to the fifth to the eighth group elements, valency of that element of those elements is equal to 8 minus group number. Means this is the fifth group elements. 8 minus 5 is equal to 3 is the valency. Sulfur is the sixth group element. 8 minus 6 is equal to 2 is the valency. Chlorine is the seventh group element. 8 minus 1 is the first number 1 valency. And argon is belongs to 8th group. That means 8 minus 8 is equal to 0 valency. What is 0 valency? The combining capacity of this element is 0. Okay, elements in the same period have different valencies. So thank you for watching this video.